Took a while. All right. Welcome. This is CS5610, yes? Web development. Just want to make sure I'm in the right place. I think the room changed last minute. It was supposed to be International Village, right? Is that right? I mean, because I checked it yesterday. I even went to the room, make sure I knew where it was. And I looked this morning, and right before coming here, I was almost heading that way, and it says, "Oh wow, it changed." So it wasn't just me, right? Yeah, I'm Jose Anunciato, and this is my name, Jose Anunciato. You can reach me either by email from the university email, or better yet, my Gmail account, or my phone number. This is my personal phone number. Don't give it out, but certainly feel free to call me, or you can WhatsApp me or text me. There's a piazza that goes along with this, and also a couple of TAs for this class. You should first, if you have any questions, you should first try piazza, asking questions there. Most likely, there's other students that have the same questions, so they could benefit from the same answer. If you don't get an answer within 8 hours or so, try your TA. They will also hold office hours. If you can't get hold of the TA, certainly text me, WhatsApp me, Google Hangout, Skype. I make myself available as much as I can. If not, send me an email, call me, right? Certainly you can call me. And also have office hours. This class is has two versions. One is face-to-face, which is right now. So this is Mondays and Wednesdays, 11:45 to 1:25. But there's an online version that is going in tandem with this. There's some folks in Seattle who are taking the same course, same material, but they won't be joining us. Although I am sending them the Google Hangout link, so they should be able to see what we're seeing. So perhaps we'll see them join. Anyway, I will record all my sessions. They will be available in my my YouTube channel, which is right here. It's just if you go to youtube.com/jnunzi, Jnunzi, just like my username, my Gmail username, you'll find my channel. All the videos that we've recorded, all the lectures will be here. Much of the videos that are in the course are also here, plus tons of other stuff. Tons of other really nice material is in there. So just a little bit about myself. I graduated last century. This makes me feel old. No, 1999, I did my PhD. I've been working since then, teaching as well. So I've been around for 15 years in the field, and also teaching as well. I have do a lot of consulting, local companies. I've been doing Department of Defense, medical, finance, telecommunications. So I think I have a broad understanding of several industries. I'm just now starting another contract at a publishing firm, first time at a publishing firm. That'll be cool. So I like to share a lot of those anecdotes from the front lines with students, and I think it has paid off. A lot of students seem to appreciate those kinds of anecdotes. And I try to do the assignments and the projects and what we're building throughout the course as close as possible on what you see in real life. Obviously, in real life, there's a project tends to be much bigger, a lot more people involved in the same project, and there's some considerations that you take when you're working in large groups than perhaps the smaller things that we're going to be building here in class. Right? But nevertheless, I will try to point out those aspects that you find in a real life setting, right? With a larger crowd, we have to work with lots of other developers, right? When the code needs to be around for quite a long time, much longer after you've gone, right? That somebody else has to maintain your code, somebody else has to look at your code and do changes. So, what kind of considerations would we take into account in those settings? As opposed to creating something that's a throwaway code, just me trying to point out a certain topic. And I'll try to do this quite often, where we'll code something very simple, just to get a point across, right? Of something, what's the hello world, the minimalist example, to just understand that small nugget, right? And then we'll step back and say, well, how does this fit in a larger context, right? How does this fit when you want to use this particular technique, but in a larger project, right? What other considerations should you consider? So often the case is that when we be talking about a particular small topic, small technique, we'll be doing a lot of bad practices, right? Things you would not normally do in a real setting, right? But nevertheless, it'll be just throwaway code just to get a point across, right? Much is the case is that if I started with a larger example, right, the point I was trying to make usually gets lost in the larger picture, right? And he says, do I also need to know all this other stuff around it to understand this little piece? So we'll try to extract those small pieces, explain that, and then put it in the context. Make sense? You should have gotten an invitation to Kata. Everybody got an invitation? Okay. And also I posted a couple of welcome messages. Did everybody get that? Yes, you should get an email right when I post these, and it goes to both classes, the online class and this face-to-face class. Okay, so sometimes you'll see me making certain announcements that are for either for one or the other, right? But I'll try to make it the same for everybody, right? So an announcement will be the same for both. Everybody familiar with Kata? Right, it's just a forum, right, where you can ask questions, right? And TAs and myself will be monitoring the forum to be answering questions there. Okay. Other students can participate as well. Certainly, if other students have answers that, please participate and answer. Feel free to comment. Right. This is the website. There's 7 modules on the left-hand side, of which only the first 2 are available right now. Okay, I'll make the next ones available in the upcoming weeks. The first one will deal with setting up the environment, right, the development environment. If you don't know yet, the course is built around a particular technique that has become very popular of late. What's called many refer to as the mean stack development. So mean, as the acronym suggests, it stands for 4 types of technologies. 4 technologies. I wish I had wish I had another whiteboard here I could write and have the. As the acronym suggests, it stands for 4 technologies. Well, really 3, but Mongo, DB, which is basically the database. It's a NoSQL database, which again is becoming more and more popular. NoSQL database have been around for a while, but you know, with larger problems that are being dealt with by Google and these other companies of the big data problem, right? That we're generating so much data, at an exponential rate, that probably generating more data than we can possibly process, right? And this has its unique issues, right? Its unique challenges, and MongoDB is one of those databases that addresses this issue, being able to to deal with large amounts of data that are geographically distributed across large geographic areas. It has its own challenges, right? So MongoDB has become very popular there, and we have a database development module which will cover MongoDB quite extensively. The other two technologies that are somewhat related are Node.js and Express. Okay, these are related technologies that allow you to very easily create a very simple HTTP server. With just a couple of lines of code, you get an up and running Node.js server that allows you to just either host static content or create web APIs to be able to map URLs, incoming URLs, right, to some back-end logic, right? Usually is what's going to allow us to not only host static contents of the HTML, JavaScript, CSS, and whatnot, but it will also allow us to create, allow the client side, right, JavaScript running on those browsers to access data in the back end, right? They can retrieve data. They can ask the server, hey, retrieve the list of users, the list of courses, the list of whatever, right, and retrieve content from the database, right? So Node.js is the kind of like a platform, right, that allows us to create these very easy, very simple HTTP servers. Express is a module that extends the ability of Node.js to be able to very easily create these mappings of URLs to backend logic, right? That makes it very easy to parse the URLs, right, that are coming to the server, right, and then associate logic against those URLs, right, and then run some backend functions, right, some processes to fulfill those requests that are coming from the client, from the browser. The other technology that is in here in this acronym is AngularJS. Okay, and this will be this will enable, this is a JavaScript library that has become very, very popular recently, that will allow us to quickly create a dynamic, very dynamic front-end user interfaces, right, that will react to user input, right, as they interact with the interface, right, and will allow us to dynamically update the UI, to iterate over data, right, and very easily update the UI as the user reacts to it, right, and go back to the server very easily, right, retrieve data from the server and update the UI accordingly. So the acronym stands for these four technologies. Many think that it's not even a framework. It's just four disparate technologies that just happen to work very well together. And there's some truth to that, right? They are independent frameworks on their own, and it's somewhat true, right? But there have been a lot of efforts at actually building it into a framework, right? That build on each other's strengths. So the course is built around this technology, right? And the various modules that are on the left-hand side will cover these various technologies as we progress. Right? We'll start at the front end, right? And we'll talk about the what are the aspects of creating a user interface. We'll talk about how to make it responsive, how to make it pretty, how to make it presentable, with creating some prototyping, real quick prototyping on with some simple navigation. Obviously, not doing any functionality whatsoever, right? Just a shell, right? And usually, creating this front end targets is based on the requirements, right? That might come from having met with clients, right? And how do you fulfill? What's the best way to present data and fulfill the requirements, right? And this drives the rest of the development on what kind of data am I going to need when, right? And what kind of services am I going to need from the back end? Yes. And so this drives also the development of the APIs that we're going to need, and that will be a nice segue into server-side programming, right? Okay, well now I know what am I going to need in each page, right? These are kind of the services I'm going to need, right? We can implement that with Node.js and Express, right? So that will be a nice segue into that. Up to this point, we haven't stored any data, right? There's no statefulness. The application can retrieve data from the server, but the data might be static, right, or might be computed dynamically on the server side. But the next step would be I want to be able to persist this data. I want to be able to come tomorrow, right, and be able to log in and the server remember me, right? Remember who I am. Identify myself and give me data that is relevant to me, right? If I entered data yesterday, I like for it to be able to be available tomorrow. Even if the server crashes, it needs to restart, right? I want it to be persistent, right? For that, we'll talk about MongoDB. We'll talk about in general how to model data in general, looking at the various entities that are associated, their association, right? Whether we have one-to-many relationships, one-to-one, and how to capture all that and see how that gets implemented using MongoDB. Okay. Towards the end, we'll be doing some securing data, right? Meaning, how do I identify the user, right? How do I authenticate the user? How do I know who this user is? And also, once we've authenticated them, authorizing them, right? Usually, security. There's two pieces of it, right? We first need to know who they are, and once we know who they are, what are they allowed to do, right? So authentication and then authorization, right? For that, we'll be talking about using a technology it's not part of this framework. At least it's not in this acronym, which is Passport.js, which is also become a fairly popular way to implement these kinds of security. Finally, we'll talk about dynamic server pages, and where up to this point we have been talking about. Obviously, we've been talking about pages are dynamic, as in as I interact, right, the pages dynamically change, right? The most basic interaction might be navigation, right? I click a hyperlink and I navigate from one page to the next, right? That's the most basic interaction, right? The UI, I see the UI taking some kind of action, right? As I click and make this very simple interaction. Or a simple interaction might be, I submit something, right? Submit a form, and somehow the back end responds with the data that I give it. But what in the up to this point, we'll be looking at even more interesting interactions, right? As in, I can drag things around, right, and reorder things around, right, or remove records, and without refreshing the page, right, the elements are removed right from the UI, right? Without so dynamically, as in the page is not refreshing, right? The re-rendering, typically submitting a link or clicking a link typically means load an entire new page, right? Or submitting a form also typically means navigate to the next form, right? Or next page, right? With perhaps the results of having submitted the previous form. Yes. Well, those kind of interactions are somewhat old school, right? They're still there, they're still useful, but of late they have become somewhat legacy ways of building web applications. Right? They're still there. They're still very useful. They'll be with us for quite a while. Right? And oftentimes we developers we love those. We love being able to refresh the page. Just throw everything away and just restart the page, and any memory leaks that we might have been accruing, we have, be able to refresh the page is very, very, very nice. But of late, has been very common to create applications that are very dynamic, right? Users have been using desktop applications for quite a while, right? And in those applications, they've become accustomed to having those applications very, very responsive, right? They can drag things around, they can move things around, right? And they've come to expect the same kind of behavior from the web applications, right? From the web, right? They says, well, why can I do this in desktop applications, but I can't do that in web applications? Also, with more and more people having mobile applications and more people accessing things on the web, a lot of applications are moving to the web, right? Google Docs, right? You have now these very powerful PowerPoint replacements, right? You have these spreadsheet implementations, these Word Word document replacements, right? That allow you to have a full-blown application, right? Running on a browser, right? Very, very dynamic, right? You see when if you reply or click or remove or whatever you do to elements on the page, they're very dynamic. They're very responsive to what you're doing, right? You don't see a page being refreshed, right? So those kinds of applications, have their own challenges, right? And AngularJS, right, the technology we'll look at in a couple of weeks, right, is it's built towards that to fulfill that requirement. Where we usually refer to those kinds of applications, we refer to them as single page application. Right, single page application, meaning, what does that mean? Does that mean that you visit a page and then you never leave that page? Well, in a sense, yes. You load one page, and typically you stay in that page. It doesn't mean that page, it'll always look the same, right? It doesn't mean you won't have navigation, right? It means that the way it's implemented is that there is one page load, right? And any updates within that page, any functionality, right, is all implemented in that one single page, right? Even navigation, even if I click on a link and I would expect to see another page, maybe I click a tab or, right, and my expectations would be that I see something different, right? Right? Even that, right, it would be a complete replacement, right, dynamically, right on the same page, though, right? That means a lot of dynamic manipulation, using JavaScript, manipulation of the DOM, right? Either throw away the DOM and re-render the entire DOM on the same page without ever leaving that. I mean, if you go to Google Docs, right? That's a single page application, right? And you're coding and you're doing all sorts of things, and you're writing and you're doing all sorts of interactions. That page never reloads, right? Or Gmail, right? Another one, or Google Maps. I think Google Maps is the first single page application that really caught our imagination. It's one of the first applications that wow, it loaded and I'm scrolling, right, and I can go anywhere. I can zoom in, zoom out, and have all these dialogues, right, and data is being loaded dynamically in the back end, right, where it's hitting the server. You're downloading those images dynamically, right, as you zoom in and zoom out, and you scroll back and forth, right, and you click. And you see dynamic data being rendered, those dialogues. I think it's one of the that really opened our eyes. Is wow, right? The things you could possibly do, right? That it is achievable. So AngularJS certainly is it's target implementation. Okay. So yeah. So how do I use this? We mute the projector. Is mute microphone volume, program volume. What's that? Does that do? No, that's not it. Can I go to a blank page? No blank page. Anyway, what I wanted to point out is the two types of architecture, right, that have been with us and where we might be going. So here's I like to talk about two architectures in general that one that has been with us for quite a while and one that you might be familiar already with, right? And what where we're moving towards, right? Or what has been becoming more and more the norm of late. Okay, the typical architecture we've been looking at these past decade or so, right, has been where you have pages here, right? Perhaps HTML, right? Obviously, but also, erase. This is erasable, yes. Right, and this is typically being hosted by a server, right? Perhaps this is in a file being hosted by a server. Right, here's the server, and the server typically is waiting for requests from various clients. Right? So here's various clients that provide and make an HTTP GET request, right? Providing a URL, and the URL might start off with the protocol. It might provide a domain, right? It might be CNN.com, right? And then provide some path here, right? And perhaps optionally some document, right? That comes into the server. The server looks at this URL and then maps it to a physical file, right? And its local file system, right? And then what it starts doing is it starts responding, right? It creates a response, right? So this is a request, right? And it creates a response, starts streaming this content back to the client, right? And then once the client renders the page, right? In that page, it might have links to other pages, right? And if you click on that page, right, it makes a completely different request, right? Asking perhaps for another HTML document, right? And again, it starts streaming the HTML document back to the client for rendering, right? It typically means that whatever parsing of the original page gets thrown out, right? We're re-rendering an entire new page, right? Even if the content is mostly the same, right? The page is completely being re-rendered by the client, right? And the server is sending over all the content back, streaming it all the way. Everybody okay? Right. And this is true, right? If this is a request from other clients, right? And there have been ever since the the beginning of the web, developers have been looking at how do I push this forward? Right? How do I make this more interesting? How do I make it more dynamic? Right? How do I make it so that if it's two different clients, could I give one client one experience and the other client some other experience? Right? Perhaps if they identify themselves. So how do I do that? Well, it used to be that we couldn't do that, right? There was no way for the server to distinguish from one client to the other. Right? We say that the HTTP protocol, we used to say it's stateless, right? Well, it's still stateless, right? And so we're looking for other techniques. How do we do this? How do we distinguish one from the other, right? We came up with the solution saying, well, what if in the request, right, we send over some additional information, right, that identifies us uniquely, so that the server can look at this additional information, right, and says, oh, it's you, or it's that. Now I can identify each other, right? And we call that technology the cookies, right? The cookie. Cookies now were small pieces of information that uniquely identified a client, right? That were passed. This one had cookie 1, this one had cookie 2. When they each passed the HTTP request, they passed it as well, right? Now servers could take that cookie and do something with it. Well, not if they were serving HTML, right? HTML, there was, how if I want to be able to look at this cookie, well, HTML, there's no way for HTML to be able to look at cookies, right? There's, it looks like I want to programmatically look at this cookie and do something with it, right? So we invented other techniques, right? Of how to, instead of serving static counting HTML, we came up with, well, what if we had a technology that allowed us to generate this HTML dynamically? Meaning, you have the URL, but I would like to have this HTML not static. I like to dynamically generate this, right? Maybe I want something for a different time, depending on the time of the day, right? I like to change what it is. Weather applications, right? If it's a weather application, I like to be able to give you different response depending on the day or the time, right? So you can't do that with HTML. So I like to calculate the HTML as opposed to be static. So we came up with all sorts of competing technologies. Right? We have ASP, JSP, PHP. There's tons of these, right, around. These are server-side technologies. Right? These are server-side technologies that, when the URL comes in, right? Now the server looks at these, right? And what these are executables, right? These are executables that don't just have HTML. They might have mostly HTML, but they have embedded code in there, right? In whatever favorite language of yours, right? Either .NET or Java or PHP or whatever, right? You have embedded code that can run here, right? Perhaps look at the time of the day, right? Maybe now we can perhaps parse this cookie, right? Take the cookie from the request, right? And then do something about it. Says, oh, it's you, right? If it's you, I'll show you something, your shopping cart. If it's you, I'll show your shopping cart, right? Typically, all that data would be, perhaps in a database where we have some mapping, some user table, and then some data that maps to each user, right? And we can, retrieve from the cookie, knowing who the user is, and then retrieve information for that particular user, right? And we have these now because this is running on a server, right? The server, you could, whatever you could possibly do on these using these powerful languages is now accessible to you in these server-side technologies, right? You can connect to a database, right? You can do network connections and connect to a different network, right? Anything that you could do in a desktop application, right? You have the full-blown power, right, of these powerful languages, Java, PHP, .NET, right? Notice that the clients, right? The clients kind of, the original intent that these were kind of dumb clients, right? And it still is, right? The intent is that these are dumb, right? They're only used for presentation purposes, right? For display purposes. They just display data. They just need to know where to get the data, right? Here, these URLs would come in. They would retrieve a page and render the page, right? And this was the model, right? This was the the basic web development model for a decade, perhaps. Okay. Had been around, perhaps late 90s, early 2000s, right? This was kind of like the way we were building applications, right? And there's quite a lot of effort that we spent on building this, right? And we learned a lot on how to build these things, right? There's a lot of, this became very, very mature technology. Well, it still is. It's very, very mature technology. Very, very solid technology. And a lot of things that we learned of implementing these web applications are trickling over, right, to client-side programming. Okay, a lot of the design patterns that we discovered here, right? Inversion of control, the controller pattern, right? Singletons, all those design patterns, model view controller, all those design patterns still apply. Right? And a lot of those ideas that we discovered implementing these things, they're trickling over now to the client. Right? On the client, right? Some folks said, wait a minute, but there's a lot of there's a lot of stuff here that I am reusing, right? I mean, I want always the same header, right? I kind of want the same navigational everywhere, right? I kind of want the same footer, right? Perhaps the only thing that changes is content, right? So there's a lot of techniques on the server side that allows you to perhaps split this off, right? That here you have a page, a header, .jsp, right? And then you maybe have a footer, .php. Well, not different technologies, right? They have to be the same technology, right? The same framework. But nevertheless, all these frameworks kind of went the same way, right? It says, ooh, I like to be able to maybe load these, right? These snippets of code, so I don't have. So each one of these individually, where the content is, the content doesn't need to know always what the header is and the footer is and the navigation is. I could separate those things, right? I could separate those things, right, and load them as I need to, right? Still, for every page that I was accessing, right, the same HTML was being streamed over to the client, right? If I went from one page to the other, there was a lot of optimization that happened on the server side, yes, on how to include things, right? How to break things up into small nuggets, yes. But still, the server was still always sending the same header over every time I went from one page to the next, yes. So that was kind of wasteful, right? That even though the header didn't change, right, as I navigated from one page to the next, it was still being streamed to the client as I navigated from one page to the next. So a lot of optimization on the server side, very little optimization on the client side. So people started saying, so wait a minute, what if, right, we take that same idea, right, that of breaking things up on the server side, what if I could do that on the client side, right? On the client side, could I, ask for the headers and the footers and the content separately, right? Build the page on the client side, and then only ask for these guys, right? And not have to ask for the headers and the footers ever again, right? Okay, so what if I could do that on the client side, right? And that it started like that, right? When we started looking at implementing such frameworks, right? We looked at what can we do with JavaScript. So JavaScript is the technology, right, that allows us to program things on the client side, on the browser. This is code, right? It's a interpret language that lives and runs on the browser, right? It allows you to interact with the browser, ask it, how big is my window, right? Right, you can create event handlers, right, to detect mouse movement, right? Page resizing, notify when the page first loads or the page unloads. You can basically, it's a programming framework on the browser, right? And obviously you have different concerns here on the server side and different concerns on the client side, right? Here it's typically mostly for presentation, right? Whereas here it's mostly, it's data driven, right? You have a lot of data modeling and things like that. But over here, the JavaScript is mostly concerned with interacting with the user. How do I receive user input, for validation purposes, right? For immediate feedback to the user, right? Handling dialogue and messaging and things like that, error messaging and whatnot, right? But still, it's a full-blown programming language. Okay, so with the advent of new technology that was added, well, it's been there for a while, JavaScript Ajax, right? Now we could dynamically, right? Instead of asking for an entire page, with Ajax, right, what we could do is ask for snippets, right? Or not even snippets of code. We can ask for snippets of data. Just snippets of data, right? JavaScript, allows you to dynamically, once the page loads, dynamically add content, remove content, hide content, show content, move content around, right? Color content, right? Highlight, makes things blank, right? Allows you to make the content very, very dynamic. Anything you could possibly anything. You could possibly expect a desktop application to be able to do, right? If you were writing, something in Visual Basic, or Java if you're writing a desktop application, right? Anything you could possibly think that you could want to be able to interact with the user, dragging and detecting all sorts of mouse movement, right? Those are all available in JavaScript, right? And just like in a desktop application, you would expect to be able to perhaps resize the window or animate things that move from one place to the other, or show one content and hide other content, right? Or perhaps, just like in the desktop application, you might have tabs, right? And as you click on various tabs, you see different content, right? Right. So the same thing you would expect to be able to do in desktop applications. With JavaScript, you can do the same thing, right? It's a little different, right? Typically, if you're doing desktop applications, you're using Visual Studio or using these or Eclipse or one of these desktop IDEs. Typically, if you're using these frameworks, typically there's tons of widgets that you can drag and drop. Right? You can, let me drag here a tab, and let me drag content in the first tab, and content in the second tab, and content in the third tab, right? And these frameworks are fairly mature, right? They create all the code behind that you need, right, to fulfill all the typical controllers, right, that you need for detecting mouse clicking, right, and navigation between the tabs, right? We're almost there. We're not there in JavaScript. You can do all these things. There's tons of widgets, right? They are available. jQuery. We'll spend a couple of weeks doing jQuery and jQuery UI. We're almost there, but we don't have the same support, IDE support that Visual Studio or Eclipse might give you of dragging and dropping things around, right? Although you can implement the same kinds of functionality, the same kinds of behavior. We still have to do a lot of hand coding, okay? Right, and there are some IDEs that have done some ability of doing some of the same functionality of mature IDEs, right? But you still find yourself doing some hand coding, right? So we'll get our hands dirty, right, and actually physically, manually have to link things together, right? Do some event handling ourselves, okay? But if you can think of any application that you can possibly think in a desktop application, you should also be able to think that yes, I can do the same thing on a web application, right? You shouldn't think that you're limited in any way because you're on a web browser, okay? Today you can think of the web itself, right, as a legitimate development framework. Okay, HTML, CSS, JavaScript, and these frameworks, right, AngularJS, right, jQuery, all these are making it easier, as we progress, easier and easier to create legitimate, full-blown applications on the web. All right? If you can think it, you can build it. Right? So think big, right? Don't limit yourself, right? So now that we have JavaScript and Ajax, the architecture changes a little bit, right? The architecture changes a little bit, right? Instead of having these, asking for various HTML documents or even JSPs or PHPs or ASPs, lots of documents as I navigate, right? As I move from one section of the application to the next, right? The architecture changes a little bit. Instead, with this technology of JavaScript and Ajax, I ask for the page once. Okay, I ask for the page once, or much less time, maybe a couple of times, maybe. There might be distinct functionality in an application that it might warrant a full page reload. Okay, perhaps like there's a very good distinction between Sheets, Google Sheets, right, and Google Docs and Google PowerPoint slides, right? They're so distinct that they made the decision that these make sense, that if you're going to go from one to the other, they all live in separate pages, right? You could envision that it could have been just one big application where you can just navigate from one to the other, right? But they're so distinct that it makes sense that these are separate, right? And they have all each dedicated pages, right? So once this loads, the HTML also asks for additional resources from the server, such as other documents like JS, right, JavaScript. It downloads those right to the client, and might go off to the cloud also, right? Go off to the cloud and ask for other JavaScript files, right? Go off to jQuery and download jQuery, right? Might go off to Google, right, and download some of their libraries, right? Because maybe I'm going to do some mapping, right? Some Google Maps, right? It might go off to IMDb for downloading some of their libraries because I want to, I'm doing a movie application and I want to look at some of their content, right? Perhaps I'll go off to somewhere else to download some CSS, right, from Bootstrap because I want to, Twitter has made a really good job with creating this, very nice set of CSS libraries that allows us to really quick implement nice-looking applications. Download it all into one HTML. Some of our own CSS, right? Some of our own CSS, some of our own JavaScript, right? But some of the distributed across, right? All in here, running from our own JavaScript, right? Our JavaScript that's going to take all these resources, right? And now, no more page loads. No more page loads, right? The framework, the architecture changes a little bit, right? Instead of having many HTML requests, right? We will still have lots of. Oh no! Did I just drop that? That's full of stuff down there. Wow. It's a cemetery in there. That's where the erasers go to die, huh? So we download one of these HTML, right? But then what we do is that the subsequent queries, all right, there's still going to be HTTP gets, right? But they're not going to get content. They're not going to get content. I already downloaded content, right? I already downloaded the DOM that I need, okay? Now I'm going to go get data, only data, right? I might download an HTML page that has a lot of the maybe the marketing, right? Some of the nice graphics, right? Something that will catch my client's eye, right? And their attention, right? Humans have very small attention span, especially now that we have mobiles and we used to say that we used to have a 5 to 7 minute attention span, right? That presentation should not be longer than that. I think it has gone down maybe to 5 to 7 seconds, right? If the page doesn't respond in milliseconds and don't grab our eye, we're out of there, right? We're ready to leave, go somewhere else. So anyway, so that first HTML perhaps, or that first JSP, or that first PHP, or that first ASP, right, renders the page, right, and catches our human eyes, our human attention. Behind it, right, asynchronously, we might be doing AJAX calls, retrieving data, right? While the human is reacting to this beautiful page, we might be still, getting data, right, to dynamically fill in some of the blanks, okay? And we might be retrieving data from the server, still URLs, but the server is not going to respond to any of this static content, right? Instead, what the server is going to do is go out to the database, retrieve data, right, and send back just data in the format, in a JavaScript format, right? In a JavaScript-friendly notation, right? Called the JavaScript object notation, right? It's an object notation that represents name-value pairs, right? Arrays, strings, numbers, all sorts of things, right? Anything that you could possibly think that you might have in objects, right? Might respond with data, and then the client, again, in JavaScript, use that data that is coming from the server to dynamically render a list of things, right? Render a list of courses, list of users, list of products, yes, right? And as the user interacts, right, as they click around, right, in the buttons or links, or as they hover, right? We might go fetch more data. Go fetch more data and more data, right? And the data comes in, and we dynamically, using JavaScript, right, we dynamically update the DOM, right? The document object model, right? When the HTML is parsed, right? When the HTML is parsed, the browser, converts that HTML into an object instance, right? It needs to parse it and create some electronic version of it, right? And that electronic version is what we call the DOM, right? The document object model, right? And with JavaScript, we can programmatically modify that DOM, right? We can hide things, add things, remove things, style things, right? And that's what we're going to do. JavaScript is going to do that. We use JavaScript, and this has been around. We've been doing this for quite a while. We've been doing it so long, right, that patterns have started to appear. Best practices have started to appear. Right? Industry best practices have started to mature. Right? Instead of doing this with native JavaScript, right, instead of doing this with bare bones JavaScript, people have said, "Oh, wait a minute. There's a lot of things that I tend to do over and over. For instance, the same JavaScript that I code, I coded it, right? Because I wrote the HTML, I wrote the JavaScript, right? Is being accessed by Chrome, and mostly works in Chrome. My JavaScript mostly works in Chrome, but it doesn't tend to work in IE for some reason. And why is that, right? Or it works, half the time, right? But sometimes it works in Safari, but sometimes it doesn't work on, in Opera. What's going on here, right? And we've been trying to solve this. And the way we used to solve it is we used to have lots of, if this, if it's this browser, do this. If it's that other browser, do that. If it's right, we write the JavaScript here. We are the developers. We are on this side, right? We're implementing this, including the JavaScript. We can't control the browser. Right? We can't control who's visiting us, right? So we have to write the JavaScript when it gets downloaded to be friendly to all browsers. Yes? Well, that proved to be such a nightmare. Different browser versions, different JavaScript engines, right? That somebody came along and solved this, right? They wrote a library called jQuery. jQuery, we'll start in a couple weeks, maybe next week. They wrote this library that says, you know what? Instead of you having to write native JavaScript and having to deal with all this idiosyncrasies of, is this version or that version, let's create an abstraction, right? And say, forget about whatever browser you think you're running on, right? Let's create a virtual browser. Let's create an abstraction, right? That if you code to that abstraction, then jQuery will figure out what version of browser, right, they're working on. Yes, and it will convert it into that particular browser's idiosyncrasy. It will implement it so that it'll be, it'll behave the same way across browsers. Right? So that's one of the big things that happen in web development. jQuery, it's the most popular JavaScript library. Definitely encourage you to use jQuery. We'll spend a couple weeks playing around with jQuery. Right? We won't have time to cover all of it, but certainly we'll cover what you'll be using most of the time. Right? But there's a lot of really powerful techniques. Right? Another thing that starts to happen is that as we looking at creating these dynamic applications, some other frameworks start to appear. It says, when we're doing server side, doing JSPs and PHPs and ASPs, we did a lot of design, right? A lot of design patterns we identified that were very useful. One of the most popular and most useful of these design patterns, right, is an architectural design pattern referred to as MVC. Right? MVC is a model view controller. Right, and it's basically it's a design pattern that says, whatever you're going to be building, typically, whatever you write, it falls into one of these large 3 categories. Okay, you're either going to be dealing with data, right? You're retrieving data, storing data, modifying data, right? And you should create, you should use good database design patterns, right? You should create abstractions that represent those entities, right? Those rows, those tables, the relationship between those, right? And you should create some kind of object model, right? That is an abstraction of whatever is being stored in the database, right? Whether you're using an object relational mapping, right? Whether you're using some caching, whatever we're using, all those concerns fall under that, right? Fall under that bucket, the model, right? The other buckets, the view, right? Those are all the concerns that all the concerns about how to handle the user, right? How do I present the data, right? Do I split the data in various pages? Do I show it all in one single page, right? How do I handle events as the user interacts? When they click here, when they click there, they drag, right? I need to handle those events, right? I need to capture those things, right? How am I going to present this? What colors am I going to use, right? How am I going to lay out the page, right? All those kinds of questions, right? They all fall on this large bucket of view. And notice that they're distinct, right? There's a mantra saying that the model shouldn't know anything about the view, and the view should not know anything about the model, right? And the idea is that you might have, for the same model, or for the same data, you might have different ways that you might want to display the same information. Okay? For instance, the same information could be displayed differently for if you're an admin user, right? Or if you're an end user, right? If you're using Facebook, you're as an end user, right? You see your information, right? You see your posts, you see your friends, you see things. It's a sliver of the data that pertains to you. Yes, and each user has the same experience, right? They're all looking at the end user view of the application. Okay, if you're an admin user, perhaps working at Facebook, right? You can see the same slides, right, for a particular user, but typically you're not going to display it the same way, right? Because for an end user, yes, I wanted to scroll, endless scrolling, and I want videos to auto play or not, right? I'm going to have lots of ads, yes. So as an end user, that is my view, right? It makes sense that is my view. But as an admin, I can look at the same information, but I don't care about any of that marketing stuff, right? Any of that, right? Yes, I might just see you as a row in a table. Yes, same information, right? But displayed differently, for different users. Make sense? Same data, but different presentation of the data. Okay. Another classical example is that you might have 3 numbers, and that's the raw data, right? But you might have different ways of representing it, right? You might represent it as a pie chart, 1, 2, and 3, or you might represent it as a bar graph, right? Or any different ways of representing it, right? And these should not have to know anything about it, right? The data should not know how it's going to be rendered ultimately, and the view should not know how the data is, because this might be related to other pieces of data, right? Those relationships, right? The view should not know those things. Well, how do you create these relationships? Well, that's where the controller fits in, right? The controller, right? It's kind of like the traffic cop that says, "Oh, the user just added, just posted something, right? Or the user just commented on something, right?" The controller is kind of the middleman that says, "I will map those user interactions, right, with actions in the back end, right, with logic in the back end that will fulfill those requests, right?" It knows, it's kind of like the mailman, right, that says, it looks at the address and says, "Oh, this is for this person," right? Oops. Right? And so traffic app, and it might have some logic in saying that certain things might have to happen in a particular order. right? Or there might be some dependencies, right? You can't do this before doing that, right? It's like the traffic app saying, I will take the user input, as a suggestions of things to do. I will buffer them perhaps, right? And I know who fulfills those things, right, in the back end, right? And modify the model, right? Ask the model to change itself, right? And then when the model changes, I will notify the view that this is the next thing that the user should see, right? If they ask to remove a record or remove a post, right? I will consult with the model if it's okay to remove a post, yes, or comment on a post. The model will either fulfill it or not, right? And it will respond to me with data. Then I will then provide the view for rendering. Okay. Anyway, so this model, this design, the model view controller design pattern has been around for quite a while, right? And has proved very, very useful for implementing, web applications, right? Today, the model still stands, right? And a lot of things that we learn here, we're going to reuse those kinds of things, but we're going to reuse it. Well, not but. In addition, not only on the server side, but we're going to use that also on the client side, right? The same things that we learned about those things in the server side, we're going to use that on the client side as well. AngularJS, right? Which is a JavaScript-only technology, right? Makes use of this design pattern, right? To split the different concerns, right? What is the user seeing, right? What is my representation of the data, right? And how do I map user events, right, to that manipulation of the data, right? But on the client, right? Only on the client, right? All right. Any questions so far? All right. All right. Some logistics. All right. So as I mentioned, this is the website for the class. I believe I posted this on Piazza, right? The URL. Everybody got that? Yes. Right. So the first assignment will be for you setting up an environment. So the environment, basically, it's going to consist, for now, right, it will consist just with Node.js, downloading and installing Node.js, right? So Node.js is that box that I showed you in the middle, the server, right? It's a server who is going to receive requests, HTTP requests, right? And then fulfill those requests, right? Either go to the server, to the database, or fulfill it with a static file or whatnot. It's going to fulfill those, right? So in this first module, which is basically this week, right? You will be downloading and installing Node.js. It's very simple. You'll navigate to the Node.js website, nodejs.org. And it's available for most OSs, right? I'm guessing we have Windows, Linux, and Macs here. There's implementation for all of your operating systems. You should download it, install it. Okay, when you download it, it'll download an installer. Okay, you should run the installer, and we'll add a couple of commands in the command line. Okay, two of which we're going to be using fairly frequently. Right, one is Node executable itself. Right, the way it works is that just like anybody use any Java developers. When you compile something in Java, if you want to run it, typically you use a Java virtual engine, right? You say Java and then the class that you want to execute. Yes, right? Well, Node.js is the same thing, right? What Node.js is, right? It's very simple. What Node.js is just the ability to execute JavaScript on the desktop. That's all it is. right? Up to this point, typically when you think of JavaScript, everybody thinks, oh yeah, so that's a client-side, browser-only programming language. Yes? Well, JavaScript is becoming very, very popular, right? And it's taking over the world. It used to be that you had JavaScript on the client, right? On the server, you had maybe ASP or JSP or PHP, right? And you had these two different languages, right? So you had JavaScript on the client, PHP on the server, and then MySQL on the database, right? And so there was three disparate technologies, and you had to convert between these three, right? Well, there's a relational database, right? Have to convert it into tables and records and primary keys and foreign keys, right? And inserts and updates and whatnot, right? And make sure that have referential integrity and all that, right? Then you have in PHP or ASP or Java, right? That has to be there has to be an object model, yes? And I have to have an object representation of those tables, right? I have to have entities. Right? I need to convert, read from the database and kind of fill in the objects, yes? And then if I need to send data to the client, well, I need to convert it into a different notation, right? I need to convert into JavaScript object notation. Three conversions, three representations of the same data. JavaScript object representation, Java or ASP object representation, and then the data, right? The MySQL relational database object representation. It was a nightmare, right? And there's many technologies that allow you to easily convert between these worlds, right? There's object relational mapping technology that allows you to convert between relational databases to object models, right? Entity framework in .NET, right? What's the Java equivalent? JPA, thank you. Entity beans, thank God they're gone. And that allows you to convert between these two worlds, yes? But then you also have ways to convert between JavaScript and these object models. Today, in the mean stack, we won't have that issue. We won't have that issue. It'll be JavaScript all the way through. It'll be JavaScript on the client, on the browser. It'll be JavaScript on the server, right? And it'll be JavaScript on the database, right? One language to rule them all, okay? So download Node.js. And again, Node.js, the only thing it is that it allows you to just run JavaScript on the server. The other technology, or the other executable that Node.js is going to install for you is npm. So, like most frameworks, or most languages, I should say, most languages are very boring, on their own, right? If you look at any particular language, I mean, they're not very interesting, they're not very powerful on their own, okay? Typically, their strength lies in the libraries, right, that come along with that language, right? Why is .NET powerful? Because all the support that Microsoft gives, right? And all the libraries, all the very useful libraries. Why Java is interesting, right? Because there's a lot of open source community that creates all these very interesting libraries that come along with a framework. Yes. Same thing with Node.js. Node.js is on its own, it's not very interesting. Okay? We like to be able to extend it by installing different modules, different libraries, right? npm, right? It's the Node package manager, right? It allows you to install new packages, right? One of the most interesting packages and popular packages that we won't be able to live without, right? It's Express right here. It's one of the most common ones, most popular ones, right? That basically what it does is that it makes it very, very easy in a single line of code, right? Having server running, right? And listening at a particular port for incoming HTTP, right? And maybe another line of code allows you to very easily respond to incoming HTTP requests, right? So definitely Node and npm. And do you have time? There's a clock here. Is there a clock?
It's 1 o'clock.
Huh. Okay, thanks. Yeah, we'll look at an example in a few minutes. Right, so locally you're going to have a node running on your machine, right? And your IDE, you're going to be updating code in HTML and CSS hosted in a node server. Now your source code, two things. It needs to be available to us, the TAs, and myself. We need to be able to see the code that you're writing. Okay. To do that, we're going to be using GitHub. So GitHub or Git, right, is a distributed source control software, right, that allows you to very easily share source with other people. Okay? If you don't have a GitHub account, I suggest you create one very quick. You should create a repository for this course in particular, right? And I suggest you call it, CS5610, right? Fall 2015, right? Once you open an account in GitHub, please invite me and the TAs as administrators, right? For that particular repository. We'd like to be able to see everything, right? We'd like to be able to take your code, right? Download it onto our machines, right, and run it locally. Okay. So yeah. So please create an account in GitHub. If you already have an account, just create a repository for this class, right, and invite us to that particular repository. Okay. Right. The other thing is that these repositories are public. Okay. So be careful. Do not put any passwords, any keys in these repositories, unless if you're paying for your repository, then it's private. Then you can do whatever you want. Okay, but if it's public, make sure you don't put any sensitive information. Right, it will be open and available to everybody. Yes.
I think if you guys use your .edu, you can create free.
Oh, okay. Oh, great. Thank you. Yeah, so they do that to make it private, right? And then you can put whatever you want in there. Still, invite us, the TAs and myself, right, into the repositories. The other thing is that although you're going to be able to run your applications locally on your machine, okay, you need to host it somewhere. Right? You need to put it somewhere available for you to show us what your progress is so far. Right? For that, we're going to be using OpenShift. So OpenShift is it's a hosting website, right, that allows you to spin up servers and databases for free. If you keep it small. Right? It allows you to create various instances of Node.js or MongoDB, right, and run them on their servers, right? And the way you interact with it, right, the way you host your data, or the way you publish your content is through Git. Right? So that it's going to have its own Git repository. This is a separate Git repository that is maintained by OpenShift. So there's going to be two Git repositories. Right? One which are open for OpenShift, right, which automatically gets created when you create an account, right? When you create Node.js and the instances, right? And you're going to have but that's not going to be public to us, right? We're not going to be able to see that. TAs, myself, we're not going to be able to see that content. So what you need to do is add the GitHub repository as an additional remote repository. So when you push, when you submit, when you commit, you'll need to commit both places in OpenShift so that it's live, and commit to and push also to the GitHub so that we can see it. Yes.
So would you be open to using Bitbucket instead because it provides free repositories?
That's fine. Yes. Yes. Bitbucket also is free. I think if it's up to 5 developers, right, or something like that.
So that should be enough. Right?
Yeah. Yeah. So. Right, I don't know if you have like other repos and other people participating, but
yeah, free private repositories are
yeah.
limited. So
okay, yeah, Bitbucket will be fine as well. Okay. So the first assignment is going to ask you let's see. So for first here, right? Course map. So we're here. We're module 1. We're looking at Git, Node.js, OpenShift. Lectures are 3 lectures. And one of them is installing Node.js, downloading Node.js, and some sample example that you might run locally to make sure that it's running. You should go through these videos, right? They walk you through downloading, installing, and configuring, and creating a sample application. They also walk you through using Git, okay, opening an account in GitHub, and some documentation and some clients. If you're using Windows, you have to download a Git client. Okay, there's a couple there. I give some links to some Windows Git clients. Right, I do show one that I prefer. You should become familiar with the command line Git, even though some of these have a UI interaction, right, interface. You should also become familiar with the command line interaction of Git, right? So, I recommend you use the command line and the UI only for convenience purposes. And lastly, here I have an OpenShift a set of YouTube videos, right? These don't have sound. Okay, it only just walks you. You can view them and walks you what to do to go through them. So go through them. It walks you how to create an account in OpenShift, right? How to create your first Node.js application, right? It'll create a default Node.js application, right? Which you're going to replace with your own. Right? You're going to replace with your own, and your first application will be just to create a very simple hello world HTML file. Okay, and that will be your assignment for the next week or so. Typically, this one will use just a little more time this time around, just to set up and get you going. So it will be due not this coming Monday, but the following Monday. Sunday. Okay, so you should have plenty of time to get the environment going and start talking about the following assignments with HTML, CSS, and Bootstrap. Okay. All right. So yes, definitely go through all the videos there. Most what I've talked about today is mostly complementary to these videos. Let's see. Maybe we'll have time for doing some demos here. All right. So let's do some demos here. Yes. They will present themselves in Piazza, right? And you can use their emails, right? They'll tell you what their GitHub user name is, and then you can add them. Okay, I'm jannuzzi@gmail. It's just my Gmail account. Okay. All right. Let's see. Where am I? I'm going to create a directory here where we're going to do all the work for CS5610. Right? If we go in there, right? It's empty. So the one of the first things that you might want to do is create a sample application here. So let's play around, for instance, with a toy Node.js application, right? So we'll say here, make directory simple. Let me make this a little bigger. Simple Node.js, and I'll go in there. So in here, we're gonna get started with creating a simple Node application, right? And to do that, we're gonna do npm. So npm is, as I mentioned earlier, is Node's package manager, right? It allows us to install things, uninstall libraries, right? One other thing that allows us to do is create or initialize a Node.js application, right? So if you say npm init, it's going to go into a interface that's going to ask us, okay, what's the name of the application, who the author is this stored in GitHub, you know, what version is, are there any tests? We're going to keep the all the defaults. By default, it looks at the directory, right? I'm going to take that as the default name for the application, so simple Node.js. Simple Node.js. Version 1.0, description, you know, this is a simple Node.js application. Endpoint, test command, we're not going to have any tests. This might live in a Git repository, keywords, author, I'm going to say Jose Anunciado. License if you have any licensing. And this is the way it's going to describe this project is by creating a JSON file, right? And the JSON has a very particular name, which is called package.json, right? And we can look at the content in there, and it's this JSON, or this JavaScript object notation file, right? We know that this is a JSON because we have open curly brackets outside, right? That's saying that this is an object. It's a JavaScript object. And we have name-value pairs. We have the name here, and we have the value, comma separated, or name, value, and whatnot, right? One of these names here is a sub-object, an object within an object, right? Right? So yeah, so there it is. So it's a very easy to create JavaScript objects. Now that we have that, one of the things that that would be listed also here, which is not right now, is the dependencies that this particular application might have with other packages, right? Which is not listed here. Right? One of the things that we might want to create is a server. So let's create a server. Well, let's open it up with IDE, whatever IDE you might prefer. We'll open that up. We'll go into here. Simple Node.js will open that up. So yeah, we only have package.json right now, right? So let's create here a little file here. Say hello.js. Right? So it's just a JavaScript, right? And in here, as the name suggests, notice it says .js. So presumably there's JavaScript in here. So typically you could put here anything you would you might think to put in a in a JavaScript application. So we can say, for instance, console.log hello world. Okay, and if this were running in a browser, this would display in the console of the browser, right? In the browser, you can ask to see the JavaScript console, right? And you can see it displayed in there, right? But here we're not running in a browser, right? We're running on a desktop, right? So to run this, we can see that the hello.javascript is there, right? Hello, there it is, right? Console.log hello. To run this, we can use the Node executable that you will get when you install Node, right? We can say Node and then give it the JavaScript we want to run, right? So this runs and it says hello world, right? Because it said console.log, right? And in here you could put anything you would expect that you could put in a JavaScript program, right? You can use functions, right? You can use functions, and you give it parameters A, B, right? And you can have returns A plus B, right? And so we can say console log, can't type today, add 2 plus 5. Right, if we run that again, so we have 7, right? And so anything you could possibly think that you can do with JavaScript, right, you can put in here. Well, not everything, right? A lot of things you would expect to do in a browser, you can't do here, right? On a browser, you can interact with forms, right? You can update a DOM, right? You can't do that here because there is no DOM, right? There is no HTML, right? There is no forms that you're interacting with. There is no user interface. Yes, there's all JavaScript. In the sense that you can do branching, you can do for loops, if else, right? All the switch case and everything it's accessible in the programming language is available here. Okay, makes sense, right? But running on a desktop. So what could we possibly want to do on a desktop? Well, one of the things that we might want to do is create a server. You can say server.js, right? So in here, we could create a very simple server. To do that, we can use one of those technologies I mentioned earlier, right? Express. If you go to Express, which if you watch the video, it takes you to Express JS. There it is. So, so here in this on this website, you should definitely peruse through this website. Right, we'll come to this. Halfway through the course, we'll spend a couple of weeks just working here in Node.js. Right. In here, we'll see that the latest version gives you a template on a very simple Hello World Express server. Right, which we can copy. There it is. We're just going to copy this and go to our server.js. We can paste it here, right? What this is doing is that it's using a Node.js function. Right? This function called require, right? Is Node.js's version of include or import, right? Look up this library called Express, right? And create an instance of it in this variable. Right, look up this framework, this library, and once you have it, now you have a variable where you have an instance of it. If you run it, right, it creates an instance in the variable app. Now this app, right, is going to have lots and lots of really cool functions that are going to allow you to listen for incoming HTTP requests, respond to those HTTP requests, right, do all sorts of HTTP manipulation, right, incoming requests and generating responses back to the client, right? So one of the things that we're doing here is listening. This is I want to listen to port 3000, for instance, right, at the current local IP address, right, which is 127.0.0.1. Right, I'm going to be listening at localhost, right, 3000. That's what this does. What this does is that it blocks the threat, the running threat. It says, wait, I'm listening for incoming call in 3000, port 3000. This one over here says, if an HTTP request comes in, right, with root, meaning nothing, if it's just the local host and then 3000 and then nothing after that, right, that's me, right? This is, I'm waiting for incoming get, right? I don't know if you remember, HTTP has various methods of requesting data, right? You have get, you can post, right? You can put, right? You can delete, right? There's lots of verbs in the HTTP protocol. One of them is get. It's the most common one, right? It's mostly for retrieving data, meaning somebody's coming in and they're asking for data, right? It can be used to send data as well, but mostly it's meant for requesting data, right? This one says, if an HTTP request comes in of type get, right, and it's the root, right, I am going to respond with the text hello world, right? What's happening here is that, notice that the way the response works is that we're creating a map between an incoming HTTP request and we're providing a server-side behavior that in the form of a function, meaning if this request comes in, this URL comes in, I want you to call this function. This is basically what it says, right? Now this function is using a weird syntax that you might not be familiar with, right? It's an inline function, right? It's an anonymous function. It's a function that has no name. You see that? Right? Notice that this function has no name, right? It's a function that is being passed as an argument, right? You might find that a little bit disturbing as a syntax, right? But it's very, very common in JavaScript. It's a very, very common in JavaScript that you need to start, making this secondhand, right? It's starting to become familiar, seeing this syntax over and over. Many, many frameworks use this syntax. In JavaScript, one of the features, really cool features, is that it makes no distinction of primitive data types, right, and passing as arguments, right, as functions. Functions can be passed as arguments just like primitive data types, or any other type can be passed as an argument. Now, we're more familiar with passing data as argument to a function, yes? Yes? Right? Here, we're passing a function as an argument, right? And if we feel maybe a little better, right, we could declare this function elsewhere. Maybe declare it out here, maybe, and say, you know, handle root. Okay, so that's a function, right? And then we can pass that as a name, right? If that's a little easier to read, maybe, I don't know. Right? There's some debate on best practices. A lot of people think that this is a better practice, right? That you should declare all your functions, right? And then if you're going to pass them as arguments, then pass it as argument, right? So this is what it says is that if a root request comes in, this is a function that you should run or execute. Make sense? All right. Nevertheless, you should start feeling comfortable with the other syntax, because you will see it a lot, right, in this course, right? Anyway, so yeah, so what this does is that it says this maps this incoming URL, and this function is going to be called, right? And notice what it's being passed along with that function. You see that? What it does is that Express is going to intercept any incoming HTTP request. It's going to parse the URL. It's going to parse the headers, the footer, the header and the body of the incoming HTTP request, right? And that's text that is coming from the client. Yes? It's going to parse all this, and it's going to create an object representation of that request, right? That object representation is represented in this request, REQ object. That request object in there, it'll tell you, you know, what the IP address of the incoming request, you know, who generated this request. If there are any cookies coming from the client, they're in here, right? The original URL, they're in here, right? If you have any parameters in the URL, they're in here, okay? If you have all sorts of other things, you know, if the content type that they're expecting, you know, are they expecting HTML? Are they expecting text as a response? Are they expecting a CSV? Or are they expecting an image? What are they expecting? What is the client expecting me to respond? It's in this request. Right, so in this object, I can query all these things, right? Plus, it gives us a response object, right? So these two objects we're going to use to be able to interact with the incoming HTTP request. We can read the incoming request, and then we can generate a response. Okay, that's a very common client-server, right, way to interact, right? I look at the request and I generate a response, right? That's a very common interaction pattern. Right? So yeah, so there we go. So let's run this. You can say node server. What is it? It's complaining. It says, okay, you told me to load the Express library, but I can't find it anywhere. Where is it? I can't find it. Right? And notice that it's true, right? If we do an ls, we see that we only have hello.js, the package, and the server. Nowhere do we say where the library is. We'll need to install that library, right? Again, npm. Right? NPM will allow us to do that. So npm install. So what this is going to do is that it's going to go to the repository, that npm.js.org repository I showed you earlier. Right? That's a repository of all the libraries that have been submitted. You know, there's most of them open source libraries that have been submitted. And here you can say what library do you want to install. Right? All these libraries have unique IDs, right? Unique names, right? That the publisher owns, right? This is one of them. This is one of the more popular ones, right? And we're going to say save, right? What this says is that not only do I want you to install it locally, right, here in this directory, right, but I also want you to save it in my package.json as a dependency, right? So that if anybody else wants to replicate my server, right, they can always download my code, type npm install, and they'll have exactly the same development environment as me. Okay, which is exactly what we're going to do as instructors and TAs. Right? When we publish this in GitHub, we're going to do a pull from your repository. We're going to say npm install. Right? We're going to have exactly your environment. Well, almost exactly. Right? So there. So we'll say save. So this is going to go off to the repository, right? And it's going to download all the libraries, executables, right? Perhaps do some compiling locally, right? There it is. So it downloaded, and what it does is that it downloads it into a directory called node_modules, right? Notice that that directory was not there, right? If we look at the content of node modules, we see that there is the library express is there, right? Any other libraries that you might download will be installed in this directory. Now that it's in there, we'll try the node server again. Notice that this time it didn't complain, right? But it's waiting. Now it's waiting for an incoming call. Notice that it's blocked, right? Before it didn't block, right? But now it's blocked, waiting for this incoming call. We can go to the to server and can say, you know, localhost, and it's 3000 root. We're asking for the root, and there it is. This hello world. So that hello world is the response that we're sending back from that server, right? There it is. With 2 lines of code, we have a server running, right? That it's mapped to plain text, right? In the next, you know, when we meet on Monday, we'll certainly start implementing much more sophisticated behaviors. Okay. If you make any change to the server, right? If you make any change to the server and you refresh, notice that it does not take the changes, right? Because you changed the server and the server is running, right? You'll need to stop it, right, and restart it. Right? If you refresh, the changes take place, right? There are some tools that allow you to, for instance, you know, watch when files change, right? If a server-side file changes or directory changes, right, it'll automatically restart the server, right, to make sure that you always have the latest running. We'll look at that a little later. All right, we're almost done. Let me just go over real quick. Take a look at the agenda. Okay, the assignment development. The first assignment called setting up the environment is due the end. Wait, let me see. Wait a minute. The beginning of week 3, which is really the end of week 2. Is that easy to read? I don't know. It's really the end of week 2, which is not this coming Sunday, the following Sunday. I guess should it say maybe end of week 2?
Just put a date there.
Yeah. All right. I'm trying to make this as useful, reusable as possible. But yes, so not this Sunday, the following Sunday is due. So basically, the hello world running on OpenShift, right, and GitHub, and the assignment is available. If you go to assignments, it's this over here, right? So read through this, and we can go over it when we come back on Monday. But basically, you need to create a GitHub repository or Bitbucket, which is fine. You need to create a local instance of Node.js. You need to create an instance of OpenShift and deploy your server, right, on OpenShift running remotely. Okay, and have it obviously locally, and then push the content onto GitHub so that we can see it, the TAs and myself. All right. All right. Thank you. I'll see you Monday. Oh, am I still recording?